Good morning, everyone. Today, I'll be talking about estimating price elasticity using household expenditure data, and in particular, we'll be looking at how Deaton's method applies in this context. Towards the end of the presentation, I will show how this can also be done by different income groups. German, you're able to hear me well. All good, right?
Yes, I can hear you very well. I think that the other ones are, yes, I will mute the other ones, but I can hear you very well.
All right. Okay. Thank you. Okay. Just to give a very brief outline, I'll briefly introduce the almost ideal demand system, and then briefly talk about the household expenditure surveys, and then how household expenditure surveys collect price information in the survey, and then how such price information cannot be used as such directly while estimating demand elasticities because of various problems associated with the way prices are collected in these surveys, and how Dayton's model proposes a solution for that and allow us to estimate price elasticities given the household expenditure surveys that many of the low-income countries have. And I'll also, if time permits, show how this model works in Stata using a single commodity as example. Since most of you are, I believe, all of your economists, and probably with good skills on Stata and these theories, demand theories, I don't think really I would need to explain much into the details of these models, but I'll try to quickly run through these. The almost ideal demand system is one of the many popular demand systems. This is one of the most popular demand systems out there, which is used to estimate elasticities of demand from household budget surveys. This was introduced by Deaton and Mulber back in 1980s, and it is one of the widely used demand systems. The general form of these aids with linear approximation is given here. You can see on the slide the general equation for the aids model. It starts with the budget share on the left-hand side and followed by a set of independent variable on the right-hand side, which includes prices, a set of other household characteristics typically, but we're not shown it here. And also we have expenditure, which is deflated like with the price aggregate. So this demand system has all the theoretical properties of usual demand systems, like adding up property, homogeneity, and symmetry. With the kind of parameters that are estimated, you can introduce these parameter restrictions to meet these theoretical properties in the system. And the price elasticity for AIDS model is derived using these formulas given in the slide here. I'm not going into the details of it. This is just to give you an introduction as to how AIDS model look in equations. So let me, I would come back to it when we actually introduce the Deaton's model, and I'll draw some similarities with it later on. The demand systems using budget shares, just like as we already saw, AIDS is a demand system which uses budget share on the dependent variable, as a dependent variable. So typically, the demand system estimation is using budget shares of commodity groups as a dependent variable. It is said that they may be biased even when one has perfect price measures. This is because when regressing budget shares on price, there are two pathways through which prices can impact budget shares. When the price increases, for example, the household might decide to decrease the quantity purchased, thus reducing the budget share on it. The household might also substitute to cheaper quality of the same good, which would also reduce the budget share. So because of these two different pathways that results as a result of changes in price, the regression cannot really determine whether the observed negative correlation between prices and the budget share is actually due to a response on the quantity margin or on a quality margin. This is one of the dilemma when you use budget shares as a dependent variable. And one of the other One of the more important problem while estimating demand function is the identification problem, and all of you must be familiar with this issue when estimating demand functions. In a competitive market, prices and quantities are simultaneously determined with interaction of both demand and the supply curve. Observed equilibrium price quantity combinations, however, need not be either on the supply curve or on a demand curve. To be able to actually identify the demand curve, it is important that the prices has to be truly exogenous, and the other things that affect the demand curve has to be fixed, and that is a ceteris paribus assumption that we use. And it's typically more difficult in the time series data, but in regression analysis, actually it is possible to use instrumental variable techniques to overcome problems of identification when price variable is not truly exogenous. However, finding a true instrumental variable can be a major challenge. That said, um, let us now examine, the nature of these household surveys. Um, is there some? I see some. There was some chat message. Somebody messaged me in between. Maybe we'll take up all the questions till after the presentation is over, because I probably wouldn't be able to see some messages if something comes in between. So I'll keep going. Any questions you have, we'll reserve it for the end. We'll have some time to discuss these questions and take it up at that time. So the spatial variation in prices resulting from differences in cost of transportation, differences in border taxes, etc., can be implicitly used as an instrument for endogenous price variable. In many developing countries, it is very common that the infrastructure is not developed equally among different regions in the country. So the goods are produced in some part of the country and it is transported to some other parts of the country. So the transportation cost can vary depending on, and there may be some border taxes there may be specific state or district level local administration taxes in some locations. So because of all these different reasons, you might actually see for the same commodity, the prices can be different across different regions or different geographical locations in the country. So that is a source of genuine price variation that is across space within a country. So Deaton's model is actually making use of this spatial variation that is prevalent, especially in lower and middle income countries, as an endogenous, as an instrumental variable in effect uh, to address the endogeneity issue of prices. So it is actually more common in lower and middle income countries because of the less developed infrastructure and transportation facilities, whereas in higher income countries where infrastructure is by and large equally developed, and the tax system is very similar across locations, the applicability of this model may be limited. Household expenditure survey collect data by clusters of households living close to each other and surveyed at the same time. This is very typical of all household surveys. There are villages identified, and then every household within a village are usually located in a very close geographical location with a very high proximity between them. So it's quite expected that these households who are living within a cluster or a village usually face the same market prices. So they don't really see much variation within them. So we see that the variation of prices within a village or a cluster is almost absent if you consider households in a household budget survey. At the same time, the cross-cluster variation in purchase is also seen, because it is possible that the prices faced by households within a village is somewhat different from the prices faced by households in another cluster in the household budget survey. So typically, this is the characteristics of household expenditure surveys that we see. All households within a cluster face the same market price. The within cluster variation purchases depends only on the income and household characteristics, whereas cross-cluster variation purchase could partly be due to genuine price variation among other factors. And this variation in price across clusters can be used to estimate price elasticity of demand. So essentially, if we are able to tap in this cross-cluster, across the cluster variation or between cluster variation in price, which we assume to be genuine price variation due to the reasons we already spoke about, it is said that we can tap in that variation to estimate the price elasticity of demand. Um, yeah. Next slide. So unit values is something we need to be given special focus when we talk about estimating price elasticity of demand from household expenditure surveys. In most household expenditure surveys, you will see that a typical household is asked, what is the amount of a certain commodity that you consumed over the last 7 days or 2 weeks or 1 month. And the households are also asked to report the expenditure they spend on consuming that amount of or quantity of commodity. So we basically have the expenditure spent and the quantity consumed for different commodity groups in a household budget survey. So what we get by dividing expenditures by quantities is basically the unit value. And one needs to know that these unit values are not the same thing as prices because of two major reasons. One is the quality substitution. The unit value is affected by actual prices and the choice of quality. Because if you think about it, as the prices rise, the consumers would shade down both quality and quantity. So the unit values tend to vary by less than the price itself. Comparisons of quantities with the unit values instead of prices will overstate the effect of price because of this problem. So when the quality of goods consumed varies over time or across regions, this unit value will become an irrelevant indicator of prices if we were to use unit value as price. So this is why when we are using the unit values from derived from the household expenditure surveys, we need to be careful about using them straight away as prices because of this quality substitution issue. Now, another major issue with respect to using unit values is the measurement errors. It is common that most of the household budget surveys ask households to report their consumption and expenditure with a certain recall period. I mean, you go and ask them, like, for example, how much you consumed in the last 30 days, and households basically report these quantities and expenditure based on their recall. And it is quite natural that they make errors or they don't adequately recollect it correctly. So because of which there will be some errors in measuring the quantity or expenditure or both that a household report during the interview process. And any such errors in the measurement of either quantity or expenditure or both will be carried over to unit value also, because as we already saw, the unit values are expenditure divided by quantity. So any error in measurement of either quantities or expenditure would also get carried to unit values. So we should be mindful of that also while using unit values as a proxy for prices in estimating price elasticities of demand. To the extent the errors in unit values reflecting changes in quality are uncorrelated with the unobserved characteristics in the model, the estimated price effects will be unbiased, but it is possible and even likely that quality and prices are correlated. The quality issue can be solved either by direct measurement of quality or by independent recording of market prices. Um, if not solved, there is an identification problem coming from working with three magnitudes. For example, we are working with quality, quantity, and price with the data on only two of them. So there is an identification issue right there. So how has the literature treated unit values in the past. There has been various ways unit value has been used to estimate price elasticity in the past. One, the old methods, I mean, old studies used to straight away use unit values as proxy for prices, and they simply assumed there is no quality substitution. So typically, they use household-specific unit values with missing unit values replaced by some mean unit values calculated across other households in the same region or seasons, and then or use cluster median unit values in place of household specific and missing unit values. So the idea is basically use unit values straight away as a proxy for prices without really worrying about any quality issues or issues in particular. I mean, these studies might be taking care of the measurement errors to some extent, but quality issues has been ignored in many of the studies. That changed totally when Deaton introduced his model. The Deaton's model also uses unit values as a proxy for prices, but the difference is that this particular model use a particular structure imposed by a weak separability assumption to impute the extent of quality substitution. So in effect, Deaton's model is actually correcting for any quality variation in unit values. It also corrects for measurement errors in addition to that. So sort of takes care of both the issues with the unit values that we already discussed. And then a third method is a standard price method. So here, the price opinion or market price surveys are used. You use traditional price data collected from stores while estimating elasticity of demand. Instead of using the unit value from the household budget, you can match local prices collected from other surveys with households from that particular location if you have that level of price information available outside from some other surveys. Or sometimes people even use many statistical agencies when they collect CPI, the consumer price index data, they have this raw data from which they construct consumer price indices. And this raw data typically contains actual retail price data on products across different locations in the country. So if you have access to such data at a very wide scale from different locations in the country, we could use that instead of unit values while estimating price elasticities. And basically merge those data with the household expenditure survey data. So in such case, there is really no need for a measurement error correction because you are directly observing the actual retail price data here. And there's a fourth method is unrestricted method. It basically infer the extent of quality substitution empirically by looking at the relationship between unit values and price. So for this, for one to be able to do this kind of stuff, one has to, while doing while collecting household expenditure surveys, one has to also collect data on retail prices from the same location, so that one can estimate the relationship between both. So, however, I have listed a paper here by McKelvey. I have given the full reference at the end of the slide in the last page. Um, so this paper basically gives a detailed exposition to different methods used here, and brings out the relative merits and demerits of each of these methods. So you might want to take a look at that paper. Um, so let us focus on, so the point here is to say that, Deaton's method seemed to be probably the only method given, in practice, probably this becomes the only method to estimate the price elasticity with the household budget surveys, because um, as you will see that most household budget surveys only collect these unit values, and we do not have a matching retail price data to match with these household budget surveys in reality. I mean, there are only few countries or few places where such retail price data are available to be able to match with these household budget surveys. So we are left with relying on Deaton's method and addressing this issues of unit values as far as issues with respect to quality substitution and measurement errors are concerned. So it is better to address those and use the Dayton's method to estimate the price elasticity in the absence of having actual retail price data available from elsewhere or from the same budget surveys. So now let's focus on the unit values and the choice of quality to begin. We'll be taking each of these issues one by one. We'll first look at the quality issue with the unit value, and then we'll look at the measurement error issue with the unit values, and we'll see ways to, address both. Because unit values are chosen, there is a simultaneity bias if we were to use unit values to explain quantity demanded. That is, we are actually dividing expenditure by quantity and using that to explain quantity. So there is some kind of a simultaneity happening. So unit values are positively related to income or expenditures. But despite the quality and measurement error issues, it is still worth looking at whether unit values give useful information on prices. So it is actually one of the preconditions for using this model that we should be first of all able to find that the unit values itself has sufficient variability across the regions that we are interested in. Unless we are able to find sufficient variability in unit value itself, there is no question of using these data to estimate price elasticity because first of all, after all, we're using when we are using a household budget survey, these are cross-sectional surveys that comes from a single point in time. So it is difficult to find variation in prices across geographical location unless there are some genuine price variation that is being guided by these factors like um, you know ta- different tax regimes existing or because of the infrastructural bottlenecks that we talked about earlier, or something or the other. So it is important to find this variation in unit values across different geographical regions for us to be able to use this unit value as a proxy for prices in the first place. So here is a table which gives the result of basically this table gives the result of a regression of log unit values and dummies for provinces and for quarters. So here this is the data from Pakistan. This the table is taken from Deaton's book. Um, this essentially is a result of regression of the log unit values on just the dummies of regions and seasons in a year. So you have for season one is omitted. As you can see, it's a dummy variable, and then there were like four regions and one is omitted. So the top panel is what I'm talking about. You leave the bottom panel aside. That's a different exercise. So the top panel clearly shows, these are basically showing the unit values for different products like wheat, rice, dairy products, meat, oils, and fats. So because the dependent variable is the log unit value, and the independent variables are just these dummies for different regions and seasons, you can see that the coefficient here, for example, minus 7.2 against wheat and against the province called Punjab. It means that on average, the unit value in Punjab for the commodity wheat is 7.2 rupees. That's the local currency in Pakistan. It is 7 rupees lower in Punjab compared to the base region, the region which is considered as the base group here. So there's quite a variation, like 7 rupees per kilo of wheat difference in price uh, between Punjab and another region, right? So similarly in Sindh, you will see that it is 7.3 rupees higher compared to the base region. So there's quite a few variation that you're seeing here. So in fact, if you look at all the commodities, you will see that oils and fats have much lower coefficients. The magnitude of the coefficient is much lower. And this is one of the reason being that in Pakistan, it used to be the fact that oils and fats used to be much more regulated. in terms of having similar prices. So the price variation itself used to be very low for this product. So that's the reason you actually see the unit values also varies a little less compared to other products. And also it is interesting to note that the variation or the magnitude in general for these coefficients are much higher for regional level dummies compared to seasonal dummies here. So in other words, it means that the variation across space is much larger in magnitude compared to the variation uh, across seasons in the within the same region, right? So spatial variation is very important, and that is the bottom line from this table. Um, the bottom panel on this table essentially shows the F statistics and R square from the regression of log unit value on cluster dummies within each region. So, for example, for Punjab region, the F and R square values gives the F statistics and R square from a regression of log unit values on different clusters within Punjab. Okay, so for different clusters, meaning villages here. So in other words, here the R score meaning R score is 0.33. It means that almost 33% of the variation in log unit values seen in the Punjab province is explained by variations across clusters. That is what this number means. And as you can see here, the R square statistics is close to 50% or more in many of these regressions. So this each F and R square values comes from separate regressions for separate products as well as separate provinces. So clearly, this table indicates that there is. So this basically just shows the stata command for doing that. For the top panel, you can simply do a regress command for regress log unit value or LUV item against provinces and quarters. You can with the I dot. These are two factor variables there. So you can simply do the regression. You can also do an ANOVA, which should give you identical results. So both are shown here. The observations we already noted. Provincial price differences are larger than seasonal differences. Most province means are lower than those in the base region. Oils and fats have provincial price controls, and hence the variation is quite low. Since prices should not vary by much within villages over a short period of time, there should be significant F statistics for the village effect or village dummies. Or in other words, the village dummies should explain a large share of the total variation in logarithm of unit values. And we saw that almost 50% or more of the variation in unit values were in fact explained by village dummies within each of the provincial regression that we looked at in that table. So this exercise basically tells us that if the unit tells us whether the unit values can be useful indicator of seasonal or spatial variation. So it is important to before being able to apply Deaton's model, it is important for us to carry out this kind of an exercise to see whether what percentage of the variation in unit values can be explained by variations across different villages or different clusters of interest. And that variation needs to be at least 50% or more to be more confidently able to apply this model. So let us look at the quality effects in a bit more detail. The size of quality can be assessed using a regression of log unit values on log expenditure and other household specific characteristics. This is how it is modeled by Deaton in his book. You can see his analysis of household surveys, a very famous book which has a lot of issues being discussed around household budget surveys. So the chapter 5 in that book is entirely dedicated on this particular model. So you can see how he tries to model empirically the quality here. The logarithm of unit value is regressed on expenditures and a set of household specific characteristics. We have not mentioned all household specific characteristics here, but just a sample here. The beta 1, which is the coefficient associated with the log expenditure on the right hand side, is essentially the expenditure elasticity of quality from this regression. This beta 1 is known as the quality elasticity. Because unit values vary by quality and price, we already saw that the unit values vary not just by price but also by quality. You will notice that the price is absent in this regression. And ideally, prices should also be appearing in that regression to be able to explain what what explains unit values or what explains variations in unit values. We need to have both expenditure, prices, all household characteristics, everything on the right-hand side. But you know that we don't have price data, because if we had, we wouldn't be doing this exercise in the first place. We would be using the price variable straight away. So the equation should ideally have actual market price data too on the right-hand side, but we don't have that. But instead, what data suggests is that we can assume that the market prices do not vary within each village, and it varies only between villages. If we are able to make such an assumption, we could then include prices by adding dummy variables for each village. See, for example, if we were to assume that the prices really, I mean, there is no genuine price variation within village, but the genuine price variation only happens between villages or between clusters, then we need to only introduce the dummy variables representing each clusters to capture that price variation, right? And this assumption is not too much out of place in the context of a household budget surveys, typically, because in a household budget survey, as I already explained, households within a village are typically located in close proximity to each other, which means they are all facing more or less the same price in the market. And if they're actually experiencing some difference in the unit value, and that unit value is actually driven by the quality variation, because some of them may be consuming low quality products, or some may be consuming higher quality products, and that is the reason. But it is not the genuine price variation. But the genuine price variation is what you would actually see between the clusters. So Stata has an option called areg. So when you use the areg command in Stata instead of regression command, the reg, you use areg. You can use an option called absorb cluster at the end. It essentially it is as if specifying cluster dummies for all clusters in the data. Instead of specifying all cluster, I mean, typically in a household budget survey, you will have, let's say, thousands of clusters. You don't want to specify all the clusters in the regression. Instead, you can use this absorb cluster option. The beauty is that it will report the results without the coefficients associated with cluster dummies. It will only report the coefficients associated with other variables, excluding the coefficients associated with the cluster dummies. In fact, we don't really need those coefficients. We are only interested in the other variables coefficients. So this absorb cluster command works very nicely in this context. So this is one such regression. It basically is a unit value regression as shown here. It has a logarithm of expenditure, logarithm of household, the other household characteristics, etc. Logarithm of household expenditure, logarithm of other household characteristics, etc. So this is the ln n is the household size here as one of the household characteristics. Ln x is the household expenditure. So as you can see here, you can see these are basically the the quality elasticity, basically the beta 1 from this particular regression. So the Stata command for this is the areg luv item ln x, ln h size, and z. Z is basically the set of household characteristics. Use the absorb cluster option to run this command. So price control reflects in low quality elasticities, as you can see here. For sugar and oils, so you see the coefficient is almost 0.000, meaning the quality elasticity is almost zero. The coefficient of the quality elasticity is zero. In fact, we saw in one of the previous slide here also when we looked at the variation in log unit values across different regions and seasons, we are seeing that the coefficient associated with oil and fat were much lower compared to that on wheat, rice, or other products out there. And the similar result is being replicated here. You can see which are the commodities with high quality elasticities and which are the ones with relatively low quality elasticities, like oil and fat, sugar, other foods, etc., have relatively low, whereas products like meat has very high quality elasticity, and that is natural because meat is like it's like a group commodity where you have different types of meat uh, in there, included in there. Depending on the type of meat that people consume, the unit price could vary significantly, and that variation essentially comes from the quality of meat that a person choose. So even for such a product, we see that the quality elasticity is only around 0.15. So in fact, Deaton says that from based on his experiences with the different databases from across countries, he says that it is hard to see quality elasticity is going beyond 0.15. This is kind of the rule of thumb, he says. So these results are separately available for rural and urban. This is from Pakistan. This table is again replicated from Deaton's book, table 5.2. Um, the elasticity with respect to household size tend to be large and negative when the elasticity on total expenditure is large and positive. This essentially shows the increases in household size act like reductions in income. The more heterogeneous a commodity is, you typically tend to see higher quality elasticity. The results show that quality effects in unit values are real. So however small they are, even though the quality elasticity is 0.15, we still see that the quality elasticity is for real and it is statistically significant. So we see a statistically significant quality elasticity because in fact, you see many of these coefficients are statistically significant. These are t-values in parentheses. So this is very high t-values. So most of these coefficients are indeed significant. So we have a real quality problem to deal with here. That is what this data suggests. Any positive effect of income on unit values will cause price responses to be overstated because with quality shading, unit values will increase along with prices, but not by the full amount. So the beta 1 uh, tends to 0 implies the quality shading is negligible, and we saw that only few products have that situation. For few others, many others, we have quality elasticities close to zero point 0.1 or 0.15, etc. Now, let us come to measurement error in unit value, the next important problem to be mindful of while using unit values. The measurement error in quantity will be transmitted to unit values that we already talked about. Um, this is another reason why unit values cannot be used as prices. For example, let us say the logarithm of quantity is equal to mu plus EP, ln P. And this is the standard demand function without any throwing any other variables out there. But let us say, for example, if Q and P are not really observed, either the quantity or the P are not observed, whereas instead the households report them as P star and Q star. Basically, P star is P plus an error. Similarly, Q star is Q plus an error. So both Q and P, the real Q and real P, are unobserved. What is observed is Q star and P star with some error in it. Assuming the measurement errors have variances sigma 1 square and sigma 2 square and covariances sigma 1 2, and substituting these unobservables in the first equation, and if we were to estimate it by Euler's, the probability limit of the price elasticity estimate will be given by the Plym formula right here. This is derived. You substitute P star and Q star into the first equation, and assuming the sigma 1 square, sigma 2 square, and sigma 1 2, you can derive this Plym. So So now let us now come to a functional form of Deaton's model. I mean, Deaton's model actually, if you look at this book, it takes through different stages. It first introduces it with a very simple quantity equation with the quantities on the left hand side and logarithm of unit values on the left hand side in the second equation. But then he advances to a single commodity model, which is more functional, he says, with budget shares as the first equation. Budget share equation is the first equation. It is basically a two equation model. The first equation consists of a budget share on the left hand side, and on the right hand side you have logarithm of expenditure and a z, which is a vector of different household characteristics, and then p, which is the prices, and FC, which is fixed effect, a village fixed effect. It basically works like an additional error term, and U0CH is the error on that equation. And then we have a second equation, which is an equation for logarithm of unit values. Basically, this equation models the unit value quality modeling. So logarithm of unit value is estimated as a function of, again, logarithm of expenditure, a set of household characteristics, and prices. We already saw this equation earlier, how logarithm quality equation is modeled. So since we know nothing about the prices, we have included prices in both equations, but we know that we don't have any information on prices. There is no way of finding theta or psi directly as given in this equation because we don't know the prices. But if we were to write this second equation, the unit value equation, in terms of LNPC, I mean, you take everything to the left side, keeping LNPC on the right side, and then divide it by the psi to the left side. You can express or change this equation and express it in terms of LNPC as a function of everything else, right? And then substitute that into the budget share equation in the first equation. Then the theta will be multiplied with the inverse of psi there, right? So, but if we write this LNPC in terms of the LNV, which LN unit value, income and error terms, and substitute it into the budget equation, we obtain a linear relationship between budget share and everything else. But the coefficient on the logarithm of unit value will be theta divided by psi. That is what we would get by this simple substitution here. Now, this can be estimated not by Euler's but by IV, since measurement errors will make unit values correlated with the compounded error term. But what is identified will not be price elasticity theta. In fact, the theta is really not price elasticity here, because what we have on the left-hand side is budget share. So we have to basically figure out the price elasticities from, once we are able to identify theta, we can work out the price elasticities for quantities, because what we have is the budget share on the left-hand side. So yeah, so even if we are using the IV to estimate this model, what we are actually estimating is not the theta itself, but a hybrid parameter called theta divided by psi, which will be larger than theta if there is quality shading. That is the idea. Because as you can see here, the psi on the psi is the coefficient on the unit value equation in the unit value equation. And if your beta 1, which is the quality elasticity, if quality elasticity is 0, then phi will be tending to 1. In other words, we are saying if the prices were to be equal to unit values, then the psi coefficient should be tending towards 1, right? In which case the quality elasticity beta 1 should be close to 0, right? So this hybrid parameter is what we will be able to estimate through this process of substitution here. Now, now this is time to now draw some comparison with the AIDS model that we discussed earlier. Notice that in the AIDS model, we only had a budget share equation. We had a budget share and budget share on the left-hand side, and we have a set of household characteristics and price variables, etc., on the right-hand side. Now, here we have, apart from a budget share equation, we also have an equation that models unit values, which is the unit value equation, right? So that is an addition of this model, in addition to what AIDS model typically provides. Budget share equation closely resembles the AIDS model, but unlike AIDS, the utility here depends on quantity and quality, whereas AIDS equation does not, talk about quality at all. It doesn't assume that relationship. So also averaging will remove any direct link between budget share equation and utility theory in this kind of setting. This model is a linear approximation to so Dayton doesn't want to call this particular model an AIDS model. In fact, he says at best this can be called a linear approximation to the regression function of budget shares conditional on right-hand side variables averaging over zero and non-zero purchases alike. In when we estimate the AIDS model, the AIDS is derived under the assumption that all goods are purchased, so all budget shares are strictly positive. But in this particular model, we consider both zero expenditures and non-zero expenditures. For example, here, our budget share regression will have budget shares of zeros. Zero also is allowed as a budget share, right? So there will be households who are spending, households who are not spending on any given commodity. So you have budget shares of both zero. It will be between 0 and 1. Whereas log unit value equation, the second equation, will only have the information from households who make the purchase, because you have a logarithm of unit value only for those who makes the purchase. So both these equations will have different set of observations. The first budget share equation will have all households in the survey, households who are consuming and not consuming in the particular commodity of interest, whereas the second equation will only have the positive consuming households. So since the conditional expectation is taken over purchases and non-purchasers alike, there is no guarantee that there exists a preference that generate a regression function like this. These equations no longer are within the framework of a standard demand model where quantities are a function of price and budget. Here, consumers choose not only prices and quantities, but both quantity and quality and prices, so that expenditure is a product not only of quantity and price, but also of quantity, quality, and price. So Deaton says that ideally it should be shown to be consistent with an augmented utility theory instead of the regular utility theory that we are accustomed with. So now let us get into the estimation of the model, how we actually estimate the model. It progresses through different stages. In the first stage, we remove from each of the observables the corresponding cluster means and run an OLS regression. So beta naught and beta 1 can be directly obtained from the first stage. As you can see here, the beta naught in the budget share equation and beta 1 in the unit value equation, those are straight away, it comes to you once you run these two regressions in the first stage itself. Assuming E naught and E1 to be the residuals from budget share and unit value equations, we are assuming those to be the residuals, then we can work out the variances of U0 and U1 and the covariances of U1 and U0 using this formula. Sigma 0, 0 is equal to E0 prime E0. Similarly, sigma 1, 1 is E1 prime E1, and sigma 0, 1 is E1 prime E0 plus. So we have these estimates of variances and covariances of the errors from both these equations worked out here. So basically, you run the first two regressions, and then from the residuals of those of the budget share and the unit value equation regressions, you save the residuals, and then you can work out the sigma 0, 1, sigma 0, 0, and sigma 1, 1. So these are basically variance and covariances of error terms in the budget share and unit value equation, and these are also the estimates of the degree of measurement error. Now comes to the second stage of estimating the model. In the second stage, the effect of total expenditure and demographics are removed from the raw data and budget share and log unit values. Okay, let me go back once. I forgot to say, when you estimate these equations, remember this piece prices are appearing in both the equations. We know, as I already said, we don't have price information, so we will be using the cluster dummies in both these regressions to represent price variation across price variation, because it is, instead of the prices, it is a true genuine variation across the clusters is what we are utilizing here to represent prices in this model. So we will have the cluster dummies in both the regressions when we actually run the regression. Going back here to estimate the model to the second stage. In the second stage, what we are doing is we are basically creating two variables here, y0 and y1. As uh, y0 is created from the budget share regression. Basically, it is the left-hand side budget share minus the estimated quantities of logarithm of expenditure minus logarithm of household characteristics. Remember, we have only minused the effect of household expenditures and other household characteristics from the budget share in while constructing this y0 variable. We have not removed the effect of these cluster dummies from the budget share regression that we used. Similarly, for y1, we construct a y1 variable by subtracting the effect of logarithm of expenditure and other household characteristics from the log unit value variable. Again, just like the budget share regression, we are not removing or we are not subtracting the effect of cluster dummies from this variable. So basically, we are retaining the information on basically we are retaining the information of price variation across clusters and preserving that in these y0 and y1, and only purging household specific characteristics from it. As I already said in the beginning, remember the variation in unit value that you would see within a cluster are essentially the variation resulting from household character differences in household characteristics, etc. Whereas the variation across the clusters that we are seeing is essentially the price information or genuine price information that we want to make use of while estimating the elasticity of demand. So at the household level, we are purging all household characteristics from the budget share and unit values for each of the households. So that is why we have HC as a subscript. H represents the household, C represents the cluster. So now once it is constructed, we are going to aggregate it over each cluster. Basically, we are aggregating this y0 and y1 variable for each households over each cluster and come to the next set of equation yc and yc0 and yc1. Now see the cluster, the subscript h has been removed here. Now we have a cluster level variable. So these are basically aggregated for all households within each cluster, right? And now the YC0 and YC1 has rightly the information on prices retained there. See the theta, L, and PC coming from the budget share regression, and psi, L, and PC coming from the log unit value regression. Those are retained, and the other error terms are also retained there. Okay, so now we have constructed two cluster level variables, YC0 and YC1. Now, again, notice here, theta and psi are not estimated directly from the data as market prices are not observed. We only have the dummies here, the dummies for clusters, right? But we already saw that we can actually consistently estimate a ratio between theta and psi by way of substitution, as we already discussed earlier, okay? And this phi is that ratio that we can estimate using YC0 and YC1. Now, for this, we estimate first the covariance and variance of these two variables. We want to estimate the theta, the ratio between theta and psi. To estimate that ratio, we first find the covariance of YC0 and YC1, which is given as this. And then we also have variances given as this. Now, we are familiar with this particular Euler's formula. When the standard Euler's estimator of regression of y on x is basically the ratio of covariances of x and y to the variance of x. That is a standard Euler's formula, right? But for the errors in variable estimator, the standard Euler's estimator, which is x prime x inverse x prime y, is replaced with x prime x minus q inverse into x prime y minus q, where q and capital Q and small q are the components of x prime x and x prime y respectively. Similarly, replacing y's by their first stage estimates, I mean, if we were to estimate, if we were to replace the YC0 and YC1s with their respective estimates from the first stage regressions, we would have, we'll be able to estimate this ratio phi as covariance of YC0 hat comma YC1 hat minus sigma 01 by NC divided by variance of YC1 hat minus sigma hat 11 by NC plus. Here NC basically is the number of the households in a cluster, number of all households in a cluster, whereas NC plus is basically the average number of households who are consuming the particular commodity. The households were reporting positive consumption. So that's a slight distinction you have to make there. So the price and quality effects are essentially, so the thing is here now using this so-called errors and variable estimator, basically you can see the covariance by variance is the standard Euler's formula, and then the sigma 1 by NC and sigma 11 by NC1 is essentially correcting for the measurement error basically in this estimator. So the errors and variable estimation correcting for the measurement error. So what we have here is an estimate of the phi, but we don't have separate estimates of theta and psi. Remember, theta was the coefficient associated with the price variable in the budget share equation. Unless we are able to disentangle this psi and theta, we are not going to be able to compute the actual price elasticities. But we, as of now, have only this ratio between theta and psi, right? Now, for us to be able to disentangle this, Deaton proposes a quality theory. This is the major contribution of Deaton's work. The price and quality effects are disentangled relying on a weak separability assumption. This is the crucial assumption that Deaton uses to disentangle this ratio of psi and theta. So the assumption is that the weak separability assumption says that goods in group G form a separable group in households' preferences. In other words, it means the marginal rate of substitution between different goods in a group are independent of quantities consumed outside of the group. Now, if you think of it, it is like, for example, your budget you're spending on a certain commodity is like a two-step process. First, you assign a certain budget on spending on a group of commodities, say, for example, cigarettes or tobacco, for that matter, right? Now, once you decide the amount of money that you want to spend on that group of commodity, now, how much you spend within items within that group of commodity is independent of how much you are spending in other groups. Basically, once you decide the amount to be dedicated to this particular group, then your spending decisions within that group is independent. That is what you mean by a weak separability. So if commodity groups are weakly separable, then the quality theory that Deaton proposes, it implies the relationship between quality and price can be imputed from income elasticity of quality and quantity and the price elasticity of quantity. So he says that if the weak separability assumption holds, the relationship between quality and price can be imputed from the income elasticity of quality and quantity and the price elasticity of quantity. So the formulation of this quality theory gives the relationship between quality, price, and expenditure elasticities as follows. It is given as psi is equal to 1 plus beta 1 EP by EX, where, remember, beta 1 is the quality elasticity, which comes from the unit value equation we already saw. Eta P is the actual price elasticity or price elasticity of quantity, and eta X is the expenditure elasticity of quantity. So this is the relationship between price, quantity and quality that is derived using the quality theory that Deaton contributes to this model. The idea is that the quality shading in response to price increases is not likely to be very large if the expenditure elasticity of quality, that is beta 1, is close to 0, in which case the psi will be close to 1 and the psi inverse theta, uh, which is the hybrid parameter that we are estimating, will be close to theta itself. If so, we could ignore the quality issues and treat unit values as price except for measurement error. Now, remember, only if we are able to find a beta 1 which, or the quality elasticity which is close to 0, we are okay neglecting that and treating the theta itself, and you need to adjust the model or adjust the unit values only for measurement error. Obviously, because if we are finding that the unit values do not have any quality elasticity, then we don't need to correct for it, right? So, but if the quality elasticities are significant, if it is found to be significant and sizable in magnitude, then we need to make corrections for both. Now, deriving the parameters is pretty straightforward once the formulas are given in the book, Dayton's book. Since the budget share is nothing but quantity into unit value divided by quantity into unit value divided by expenditure, we can derive the price elasticity and expenditure elasticity as follows. So given the definition of budget share, you can write it as logarithm of budget share is equal to logarithm of quantity plus logarithm of unit value minus logarithm of expenditure. We can find the first derivative of logarithm of budget share with respect to logarithm of expenditure, equivalent to logarithm of quantity by logarithm of expenditure plus logarithm of value by logarithm of expenditure minus logarithm of expenditure by logarithm of expenditure. So that leads to this formula: beta 0 by W is equal to eta x plus beta 1 minus 1. So we can derive the expenditure elasticity as 1 minus beta 1 plus beta naught by W. Remember, now we have everything to estimate expenditure elasticity. 1 minus beta 1, where beta 1 is the elasticity of quality which comes from the unit value regression. Beta naught is the coefficient associated with the logarithm of expenditure in the budget share regression, divided by W. W is the budget share itself. To get the price elasticity of demand, use the same derivation. You can find the price elasticity as theta by W minus psi. Now, to further to actually compute these parameters further, we use this particular relationship that came from the quality theory, which shows the relationship between quality, price, and expenditure elasticities as psi is equal to 1 plus beta 1 eta p by eta x. And you can substitute eta p and eta x, and simplifying would yield psi as 1 minus beta 1 into W minus theta divided by beta naught plus W. And theta can be recovered as follows. I don't want to read this out. You can read that. So the idea here is that if beta 1 is very small, if the quality elasticity is very small, this whole psi parameter there will be small, and so will be the correction to theta. So the correction that is required for theta will be much low. Once these parameters are recovered, prices and expenditure elasticities can be computed from the equations above. We already worked out the expenditure elasticity and price elasticities already. So, so this is it. The model is it is pretty straightforward. Dayton has also provided a multi-commodity model, which makes these equations a little bit more complex. It has to use matrix algebra to be able to convey this. But let's not go into that. I mean, the idea is to understand the model. Once you appreciate how the model works, extending it to multiple commodities is no big deal. In fact, Dayton has provided detailed stata codes, although those codes are a little old, not in fact little old, it's quite old. This book actually came out in 1997. So I think the original stata codes by Dayton were written in stata 4, and now we are on stata 16. So obviously, there's huge inefficiency if we were to use the original codes by D10. But it's quite a complex code, and it is quite a challenge to rewrite it in using the new stata. But we have done that for one commodity model, which I will be explaining soon, so you will know how it works. So just to recap, uh, the effects of household characteristics are removed from the budget share and unit value. Basically, that is called purging the quality effects. Any residual variation in unit values and covariance with the budget share residuals is assumed to reflect measurement error, and the first stage regression residuals given an empirical estimate of this error. The first stage regression actually gives an empirical estimate of this measurement error. In the second stage, a between cluster errors in variable regression is applied to the adjusted average budget shares and unit values. In the third stage, the prices and quality effects are disentangled, relying on a weak separability theory of quality. The procedure relies on the existence of genuine variation in price across clusters and requires that such variation be exogenous to the processes that determines the demand. It means if village prices actually depend on demand within the village, the estimates will not be consistent for all the usual simultaneity reasons. So this is very important. If we have reasons to believe that the village prices are determined by demand within the village, that means one of the crucial assumptions fail and the model doesn't hold. The consistency properties of the model parameters depend on the number of clusters and not on the number of households. As you can see here, the actual estimation of the errors in variable model happens at the second stage after aggregating the Y0 and Y1 at the cluster level. So the regression is basically done between cluster in the second stage. So it's important to have as many number of clusters as possible. So what is also important is to have a reasonably good number of households within each cluster, because we are aggregating them, right? We don't want to, I mean, of course, we know that if you aggregate only two households, that can lead to quite a bit of extreme values, right? I mean, the mean is always affected by extremes, right? So so it is good to have more number of households so that a lot of problems will be averaged out while aggregating it to the cluster level variable. But it is more important to have more number of clusters for the consistency properties of the parameters that are estimated. In fact, Dayton's experiments show that this estimator actually performs adequately well even when there are as few as only two observations per each cluster, meaning as few as two households. Also, this model works reasonably well. The intra-regional variations, and the people who have used this model, sometimes arbitrarily create clusters. Sometimes they create larger clusters so that they think that the more households can be brought in the cluster, so the averaging will be better. Of course, it will be better, but there is also a risk because on the one hand you are reducing the available number of clusters to work with in the second stage, and on the other hand, it is also possible that then some intra-regional variations in unit values because of the spatial variation will wrongly be treated as measurement error when the clusters are artificially aggregated, and it can bias elasticity estimates. So we don't want that happening. If there is genuine price variation existing between two villages, and if you were to put those two villages together to make a more aggregated larger village or a larger cluster, then it means a true genuine variation with price variation within these villages are now going to be treated as measurement error within a village, and that is something you don't want happening. Similarly, increasing the number of clusters is more important, as I already said, than increasing the number of observations within each cluster. So now let's look into the application, go into the application of it. First, scrutinizing the data, as I already said, you check the reported unit values against actual prices to see whether there is actual price variation or actual unit value variation that is happening across space, and definitely check for outliers. Clean every explanatory variables used. I mean, these are all things that you do for any econometric analysis. I don't need to emphasize this enough. Then create cluster appropriately with the objective of creating as many clusters as possible with reasonable cluster size. keeping in mind the limitations of cluster size and household size that I already discussed. Assumption of no price variation within each cluster requires both geographical proximity of the households and that households be interviewed at approximately the same time. See, so far I was only focusing on, I was emphasizing on the geographical proximity of the household, but you should remember that it is also important that these households within a cluster are interviewed at the same time. Otherwise, you would find genuine price variation within a cluster if these households within a cluster are interviewed across different times. But normally, in most of the household surveys that we have come across, it is quite normal procedure that the households within a cluster are usually interviewed at more or less the same time. I mean, typically within a week or so. So this is not a major concern in typical settings. Preparing variables, we need to have a set of variables, basically generate the necessary variables. Of course, as you by now you know what are the variables that are required. Typically, we need the budget share variable. We need the variable on unit values. So we need to create those. We have to have a set of household variables to control for the impact on unit values. So those are typically household sizes, average age of household, average education of the household members, or maximum education in a household, education of the household head. I mean, these are. This list is definitely not an exhaustive list. I'm just listing a few variables that the literature in the past has used in similar studies, and dummy variables to characterize households into social, ethnic, occupational, religious, and income groups. Dummies to indicate the location of the household in terms of whether they live in a rural area or urban area or different provinces, etc. So these are all different control variables that goes into the budget share and unit value equations to purge off their effects and basically take out the effect of only the genuine price variation that prevails across clusters. That is the idea. So now the steps that is described in the subsequent slides are essentially taken from the toolkit. Many of you probably are aware and probably have already read the toolkit. We have a toolkit on using household budget surveys to to work on different issues on tobacco control. It is available in University of Illinois website. The chapter 3 in the toolkit essentially deals with this particular price elasticity estimation issue that we've been discussing now, and it has different steps with which we can achieve this, and also for each step we have provided stata commands. I'm sure most of you are very experts in stata. You don't really need many of these commands, I'm sure, but this is there, and we have also the do files given at the end of the toolkits we can make use of. And as I already said, Deaton has provided full stata codes in his book, which also you can use to produce the results, no problems. Only thing that the code is a bit involving, because it's quite complex, because that code is written for a multi-commodity model. So the step 1 is to derive the unit values and budget shares. You basically divide the reported total expenditures on the particular tobacco products or of your interest. Let's say if it is cigarette that you're working with, you will basically take the expenditure on cigarette and the quantities purchased on cigarette and divide one by the other. For each household, basically, you are computing a unit value here. The VHC, XHC, and QHC are respectively the unit value, expenditure, and quantity of cigarettes or any other tobacco product in household H located in cluster C. And the stata commands, these are very basic. Generate UV-SIG is equal to EXP-SIG and Q-SIG. EXP-SIG and Q-SIG are the variable names for expenditure on cigarette and quantity on cigarettes that we already have. And then we generate a logarithm of that unit value. LUV-SIG is equal to ln of UV-SIG. And we also create a budget share variable for cigarette as expenditure cigarette by expenditure total. And because we are using all households, the households which reported zero consumption as well as households who reported positive consumption, we replace the BS-SIG is equal to 0 wherever BS-SIG is missing. Meaning missing means when you create the BSCAG variable, because it is dividing expenditure on cigarette by expenditure total. Expenditure total is the total household expenditure on every commodities together. Expenditure SIG will be zero not available for those households who are not reporting consumption. So for that purposes, we are replacing the budget shares with zero when there is missing. But I have observed that when the number of zeros is so significantly large, the distribution of budget share is so skewed with a very large number of zeros. If it happens typically when your prevalence of tobacco consumption or cigarette consumption is extremely low in some countries, then you will end up with a budget share variable with almost 90% or 85% zeros, and then only remaining with non-zero values. In such cases, I have seen this model sometimes give results which are not very desirable. And I've noticed that in such cases, working with only households who are positively consuming gives better results. But in that sense, we will be estimating a so-called, more like a conditional demand is what we'll be estimating then, because we are only working with households who are reporting positive consumption and not including all households. But typically, Deaton's book, he suggests that we use all households while estimating demands. But then he was actually not writing these codes for estimating price elasticities for tobacco products, but for other regular products which are by and large used by most of the households out there. So this large inflated zero distribution was not a concern for him when he was developing this model. But for our purposes, I noticed that when the zeros are extremely large, it makes sense to only work with households with positive consumption instead of clubbing all households together. In the step 2, we test for a spatial variation in unit values, checking unit values, satisfying the main identifying assumption. That is the idea behind this exercise, that there is spatial variability in unit value. That is an assumption we have to, we have to see that our data actually shows that. So this can be done by using an ANOVA to divide the total variation unit values into within cluster variation and between cluster variation. A significantly large F statistics for the ANOVA exercise leads to the conclusion that unit values vary across geographical space or clusters. A significant F statistics and an R-square value of around 0.5 is what is desired as per Deaton. The stata commands are very basic. ANOVA, LUV-SIG, clast. Basically, LUV-SIG is the logarithm of unit value of cigarettes, and clast is the cluster variable, name for the cluster variable. You can do the same thing with the regress command using the factor variable, factor I dot clast instead. Right. Now the step 3 is to estimate the within cluster regression, which is the first stage regression that we talked about earlier, equations 3.2 and 3.3 in the toolkit. So this is basically a unit value regression and a budget share regression. We already have all the variables worked out, so it is simple Euler's regression. The unit value equation allows us to check for the presence of quality effect. We discussed that the beta 1 gives the quality elasticities. Similarly, beta naught also we can work out from this example, and I already mentioned that the pi c here, pi c and on both equations, they are price variables, and we don't have the prices with us, but instead we will be using dummies for clusters in both these regressions to represent the price variation across space. So the unit value equation allows us to check for the presence of quality effects. A positive and statistically significant beta 1 would suggest presence of quality effects. No cluster fixed effects in this regression. So here you have only U1HC. The FC cluster fixed effect is not coming there. Budget share equation is a standard demand equation where the cigarette budget share, a proxy for demand, is a function of the household income, household characteristics, and prices. steps 4, I'll discuss these steps 2, 3, and 4, and then introduce the starter codes to you. The step 4 basically is to obtain the cluster level demand and unit values. Basically, we would strip the household level demand and unit value of the effect of household expenditure and household characteristics and then averaging across clusters. The primary interest is to estimate the elasticity at the cluster level using cluster demand and cluster unit values stripped of all other factors. So as I noted earlier, we are creating these two cluster level variables YC1 and YC0. They are estimated values. We are subtracting the estimated impact of expenditures and other household specific characteristics from both log unit values and budget shares to and then aggregating it over each cluster to derive this YC1 and YC0. Now let's see how it works in Stata when we implement it. So estimate unit value regression and measurement error variance first. 3 and 4 are done together. So use the areg command in Stata instead of reg command. It does the simple Euler's regression only, but with the added advantage of not having to specify dummy variable for each cluster. Instead, we can use an absorb cluster option there. So we run this regression, and then we define a scalar sigma 11, which is basically the sigma 11 we had defined earlier, the variance of the error in from this regression. So that is derived as $S_E_SSC. This is programmer's language. You can see that this will be captured. These are basically scalars which are generated while these regressions are run. So you can basically capture these macros to form a scalar there. So you define this scalar sigma 11, and then you also create a scalar B1, which is basically the coefficient associated with the log expenditure variable, and that is nothing but the beta 1 we talked about. That is the quality elasticity beta 1. So we are basically storing that for subsequent uses, and then we are also predicting the residual of this regression into a new variable called RUVSig, residual of unit value of cigarette here is predicted here. And then now we are generating this Y1C variable here. You remember the Y1C and Y0C. So this is a Y1C, and this is because it is for cigarette. I'm using the subscript sig there. So Y1 variable. So this is basically subtracting the LUV sig. You subtract estimated impact of expenditures and other household characteristics, etc., from the log unit values of cigarettes, and store that in a new variable called Y1sig. So this is run right after the areg command. In this order, as it is written here, you can first define the scalar sigma 11, then scalar beta 1, predict residuals, and then generate this Y1sig, no problems. Similarly, now come to the budget share regression. Again, you do the same areg command with the same set of household characteristics and other variables on the right-hand side using the absorb cluster option. You predict the budget share residual, predict the residuals again, and then you define the sigma 22, which is the variance of residuals there. And then we have the B0, which is the beta naught which is the coefficient of logarithm of expenditure from the budget share regression. And then you create the Y0 variable again as before by subtracting estimated impact of all these right-hand side variables from the budget share variable. And now you run another regression again using the areg command of RUV, the residuals from the unit value regression on the residuals from the budget share regression. The idea is that is how you generate the sigma 1, 2, right? So we want the covariance, basically covariance between the two residuals. So to do that, we run this regression array command again between the two predicted residuals from both the regressions, and then store that covariance into sigma 1 2 as a scalar. So that is stored there. Now, step 5 is a cluster level regression. We saw that this can be done with an errors in variable estimation. In fact, all that we did in the previous two slides here through these codes, we were basically generating the values we want for each of these. We already have defined y0c and y1c. We have variance of yc1 defined, covariance defined. We have sigma 10 and sigma 11 defined. NC plus and NC are to be still calculated, which we'll do now. The identifying assumption is that the prices vary between clusters and not within clusters. Given this, price elasticity is obtained by seeing how cluster level demand responds to changes in cluster level prices. So in the step 5, this is how we implement this in Stata. Prepare the data for between cluster regression. Basically, we average the variables y1 sig and y0 sig by cluster to generate y1 c and y0 c. And then you basically, before averaging, you have to sort the data by cluster so that every households within the cluster comes together, and then generate y0c and y1c. So y0c is basically the mean of y0 sig by cluster. So that is a stata command. Egen y0c is the mean of y0 sig by cluster. And then we are also generating n0c, and similarly, n0c is basically a count of y0 sig by cluster. Basically, the number of budget shares, households which are, n0c is basically the total number of households within each cluster. Similarly, you create y1c and n1c using same commands, and then you sort the cluster once again. Now that we have created y0c, n0c, y1c, and n1c, we will see if you now go and examine the data, you will see that every household within the cluster will have identical values. So we don't, since we are going forward, we are only doing a cluster level regression. We need to retain only one observation per cluster. So we can simply keep just one observation per cluster and drop everything else from the data. And that is what is done here. By cluster, you are keeping only one observation. So this is the stata code command used for that. And again, generate two other cluster level variables, n0c and n1c, indicating the size of the number of all households in each cluster, n0c, and the number of households reporting positive purchases in each cluster, n1c. Remember, we wanted that for this particular formula. We wanted NC plus and NC. Those are the ones that are being generated here. Using these, we estimate the average cluster size for all households, that is N0, and the average cluster size for households with positive consumption of cigarettes, that is N1. So A mean, the arithmetic mean, is what Deaton uses to arrive at these averages, because I believe we wanted to be a little bit more conservative here. Instead of using, it is the harmonic mean that is being used here instead of the normal arithmetic mean. So the A-mean command for N0C, and you store the harmonic mean from that command into a scalar called N0. Similarly, you run the A-means command for N1C variable which we created, and then create the scalar N1 as the harmonic mean from that. So now we have N0 and N1 variable generated. We have now everything that is required to work out or to estimate this phi variable. Sorry, this phi parameter here, the hybrid parameter phi. And this is simply using that formula. Between cluster regression of y0c on y1c gives the estimate of the ratio of phi is equal to theta by psi. the numerator and denominator of which are the coefficient of unobserved prices in equation 3.3 and 3.2 respectively. Instead of doing the actual regression, one can simply estimate this hybrid parameter using an errors and variable estimator. We already discussed it, for which we use the estimates of for y1 and y0 as well as the measurement error variance and covariance as estimated from the first stage. So basically these different steps here. Through this, we are essentially defining that hybrid parameter phi in the end. We first correlate the y0c and y1c, find the covariance, and then the scalar s and r are defined. Numerator and denominator for that phi variable is defined, and then the phi is generated as a scalar phi is equal to numerator by denominator, which are already defined in the steps below, as steps above. Okay, so I hope you understood it so far. And now what is remaining is simply using these equations and translating these equations into stata code. So we have the elasticity of price is given by theta by W bar minus psi hat, where W bar is the average share of household expenditure on cigarette in the sample, and psi and theta the estimates of the coefficients on the unobserved price terms in equation 3.2 and 3.3 respectively, and they are recovered as follows. These equations we already saw. So basically these stata commands are essentially estimating those parameters one by one. Because we already have the W bar is now being defined here, the mean of the W's, the mean of the budget shares, and then all the other scalars like zeta, theta, psi, etc. are all using the same formula being translated into stata codes, because we already have most of these already worked out. So the elasticity is basically EP is the theta by W bar minus psi is defined as EP, that is elasticity variable. You do a list command, it will list the elasticity for you. Now it just lists the single number for elasticity. Elasticity coefficient is what is listed. The program doesn't give you the standard errors for it. For us to be able to find the standard error, we have to use a bootstrap method to find the standard error for this. So that is what is being done here. It's just a simple bootstrap program available from Stata. Many of these steps that we already discussed now are being replicated here, and the bootstrap will basically repeat the exercise about 1,000 times, and that is what it will then list the standard errors associated with the elasticity coefficient that we estimated. That is the idea. Now, estimating price elasticity, estimating income or expenditure elasticity is the last step, where we have beta 1 is the estimate of the coefficient on total household expenditure in equation 3.2, and beta naught is the estimate of the coefficient on total household expenditure in equation 3.3, and the stata commands are given here. These are very straightforward. You can estimate the EXPEL, which is the expenditure elasticity of quantity. Now you can use the same program to derive the standard errors associated with the expenditure elasticity also. We have provided this in the toolkit. I'm not repeating it here. Now to estimate the work, and now to estimate the thing by income group, all we need is to basically define different income groups, right? Usually it is better that we have 3 different income groups. You have a low income, middle income, and a high income group. So for that, we can simply generate a income variable. Basically, in situations like this, we have the total household expenditure as a proxy for income that is available to us. You can use the X total, which is the total expenditure variable, and generate 3 quintiles, 3 terciles, basically, using this command. So we have 3 income groups generated here, and now you keep one income group and drop the other data and repeat the same exercise. So you have you basically generate one estimate for income group 1, low income group, and then repeat the exercise and create it for income group 2, and so on for income group 3. Now, some people have seen, they want to analyze it at a much more detailed decile level, etc. But one thing to remember here is that when we expand it to income levels, the number of clusters that are available for us to work with becomes significantly lesser, because it's quite possible that we we find that there are only one or two households reporting positive purchases within an income group in a cluster, right? So in such case, it becomes the model, performance might be affected, especially if you are having cluster sizes with less than two households reporting consumption, right? So you might want to drop such clusters before using them in the regression. Now, if we actually perform it by decile groups, this problem becomes even more serious. It becomes extremely difficult to find sufficient number of clusters where you have at least two households reporting consumption from each decile, right? So one has to be mindful about, once you define the income group, we need to check the data whether there is sufficient number of households, at least two of them, at least two in each cluster reporting consumption. This is very important, as Dayton himself says from his experiments, that a minimum of two households per cluster is desired, and as many number of clusters as possible to improve the consistency of the estimator. With the different definition of very small income groups, this can become a challenge. So I think that's it, and here are some readings for you. I conclude with that. I'm sorry, since this is a webinar, I really do not know how people are reacting into it, and whether people are following what I'm talking. I have no way of knowing it. I'm really sorry for that. Usually I've never done this seminar in a webinar like this. It's always been in person. So I could actually gauge, people's reactions and see whether they are actually understanding and they are with me or not, and that helps me.
Okay, I have a question. Good morning. Here in Mexico, good morning, everybody. This is Luis Huesca. Hello?
Hey, hello?
Yes, can you hear me?
Yeah, I can hear you. Go on.
Hi, everybody. Hello. I wonder about the seeds model. Thank you, Professor Rijo, for your nice explanation. I was just wondering about the seeds model. And all the features that we have seen in your presentation has been related to mostly to the model in the budget share and related to tobacco consumption. Just trying to figure out if to make it easier to apply the seeds model and not to relate all these problems of clusterization related to tobacco consumption as a single item. If you can tell us something short about it.
Well,
The question would be how to deal with with these problems in the seeds model in short.
Can you elaborate what the seeds model? I'm at a loss actually. What is the seeds model you are talking about? I need a bit elaboration on that before I can comment.
Yeah, it would be easier, to apply all these techniques in the single item detail system, the seeds model, and for example, in many projects we are working on right now, we are not using a budget share. We are just using tobacco consumption. So I was just wondering that it would be easier for the service, household service, to detect that we have a lot of we have the right number of clusters, about the number of two within each household. So the basic question, it will be like using seeds model. It will be the best thing to fit model and to obtain the right elasticities for us. Is that correct?
So are you saying that the model that you're suggesting, it uses quantity instead of budget shares as the dependent variable, and then estimate the price elasticity? But on the right hand, on the left hand side, instead of budget share, you're using the quantity straight away, but on the right hand side, you have unit values or prices. Can you, if it is unit value, obviously it has to be unit value because you don't really get the prices from these surveys. And then how do you account for these measurement errors and the quality problems that we talked about in Dayton's model? There, you're able to do that, or?
Yes, but just using the seed model, and if we use another technique, just like the two-stage or instrumental variables model, and to be sure, if we just produce the test of the clusters and looking at the number of the cluster within in our survey, we are going to be correct. In that we have the right data to work with, and then to move on to using using some other partition of income levels, like the desires, for instance.
Well, I cannot authentically comment on whether this is good or bad. I need to be able to look into the seeds model that you're talking about in a bit more detail, and to see whether this is in fact accommodating everything that Dayton talked about in terms of the problems with using unit values and in terms of capturing this variation in unit value across space, etc., in this seeds model. And if that is implemented right, I don't see any problem in using that. But at the moment, I wouldn't be able to comment on that unless I'm able to go through this model in detail.
Okay, thank you very much.
Thanks, Luis. Thanks, Lucio.
Hello.
Think Carlos has another question.
Yes. Hello, Professor Rijo. Thanks so much for the presentation. I have a question. So in one of the household surveys we have here, I'm from Peru. We have information about the total expenditures.
So
Also,
your
the
voice
quantity
is
consumed. We
breaking.
have also a
I'm not
question related
able
to
to
the
hear.
brand consumed.
I will repeat the question because Carlos, we are missing you. He's asking about a survey that they have in Peru. The survey report information on expenditure, quantity, and brand information. Do you think that using that brand information can be useful to deal with some of these problems?
Well, I mean, are you also able to estimate the prices separately for brands? I mean, the expenditure and quantity on each brand separately?
Yes.
Well, I mean, if you have sufficient sample size to estimate I mean, enough of households reporting consumption on different brands and corresponding quantities and expenditure associated with these brands, I don't see any problem applying the similar model and extend it to different brands and seeing their on-price elasticity as well as cross-price elasticity between these brands. I'm sure this is definitely extendable to that, provided you have sufficient data to do that. If you have centralized data on consumption and quantity, I mean quantities and prices, there's no reason why you should not do this with all the brands together and estimate a multi-equation model. I mean a multi-commodity model.
Right, and that will be kind of the change, right? So instead of using a single commodity, we'll use a multiple commodity.
In fact, Dayton's model actually the actual starter codes that are given in the toolkit also, we have the full commodity model where you can actually introduce number of commodities. So you can introduce number of different brands there. So you have 5 different brands you want to study. You can actually look at estimate the price elasticity for different brands and also the cross price elasticities between them. The model perfectly allows for that.
Great. Thank you very much.
Hi, Germán.
Hi.
Can you hear me?
Yes, we can hear you.
Hi, hello, Jorge Puig from Cedlas, Argentina. I have one question. Because we are working with a household server for Argentina and we have only 24 clusters. And we are observing not too much variability in the unit value. So, 2 questions. If the fact of having 24 clusters is sufficient to apply this model, and if the fact of having not too much variability is a big problem here.
Okay. Well, I mean, 24 clusters, unfortunately, is really very low in my opinion. But is it like just 1 year of data that you have? Is there a way that you can, join these same data from multiple years and then increase the number of clusters? Is that a possibility?
No, we don't have this possibility because we have only 1 year in the survey.
Okay, just with 1 year and then 24 clusters.
Yeah,
I feel it's very limited. I'm sorry, but I feel it is very limited data.
Okay. And what about using the 2004 and 2013 surveys? What do you think, Jorge?
Pardon?
And yes.
Like 2 ways. Do you think that's possible, or the change in methodology can be a challenge?
Well, I think that we can try in order to have more variability and more observations. Maybe we at the end of the day we have again 24 clusters, but maybe using the time variability.
24 cluster is like truly unbelievable. I mean, is that for a whole country or what you're talking about?
Yes, other 24 provinces of Argentina.
34 provinces.
Sorry?
There is some information at cluster level, but information is not publicly available, Trisha. Sorry about that. The information is not publicly available.
So you have 24 provinces, right?
Yeah.
So don't you think there is within each province there are multiple clusters possible?
No, because the institute here does not publish the information at more disaggregated level.
So is there no way? I'm sure the database actually. So which means your each province will have many number of households in each province, right?
Yes.
So is there no way of identifying any sub location within the province in this database?
No. At the moment, no.
Okay, so I guess probably you need to work with the statistical agencies and see if they will give you access to more disaggregated geographical identifiers from this database instead of working with provincial level data. That is probably the only way out.
Okay. Well, yes, we tried, but we didn't get success with this strategy here. But well, we will try again.
Okay, we are finishing the call. If anyone have any short question to share, it's a moment. If not questions, probably we can think in the presentation. I will be sharing the record of this presentation and we can keep talking. And if more questions or more concerns are in relation with this model, we can think in having a new webinar soon. So, any question? Yes, sure.
Yes. Yes. Hi, Dr. Rijo. My name is Alejandra Macias, and I would like to know if we can use this methodology for a panel, and how could you do that? Because we have like 5 rounds of information of household surveys, but they are not it's a cell panel. It's not a proper panel. So could we use this methodology with this information?
Absolutely. So you just need to define your cluster by the original cluster identifier and year identifier also. So joining the years and original cluster identifier, you can create a new cluster basically. And then the important thing when see, it is basically repeated. It's not like it's like a repeated cross section. It's not really a true panel, right? So so you basically club all these cross-sectional data from different rounds into a single database, and these will be different households from different rounds, no problems. But you need to have one year identifier for each of these different rounds of data, and then you define a new cluster variable with the year as one variable, and then original cluster in each of these original cluster variable in each of these rounds as another variable, and you can define a group variable as a new cluster, and then that it actually really works well for you because you have much more number of clusters to work with. You also have much larger variation across clusters because you're working with the data from different years. But one important thing to note is that when you are clubbing or combining these data from different rounds, you need to basically price inflate. Use proper inflation adjustment to deflate all the expenditure values from different rounds to a common deflator. And that is when then you need to apply the same model, and it works fine. And in fact, we have done that in some studies. There's a study in India by Emmanuel Gundon and others who have actually used a similar methodology. This is an NBER paper you can look up online, which estimates price elasticity for tobacco products in India from multiple rounds of surveys belonging to different years. So this is absolutely fine. Thank you.
Okay, just one question. We could use locality as a cluster variable. It is really good for unit value variance.
Definitely. So, ideally, a cluster should be a small geographical location, like a village in a rural area or a small urban block in an urban area. So ideally, you would see a cluster consisting of just a few 5, 6, or 10 or 15 households, not more than that. That's a typical cluster size in most household budget surveys. So it's up. That is exactly what we want. We want households in a small location so that they are all facing the same market prices.
Okay. Thank you very much.
Any other question? Okay, we are running out of time. Thanks, Risho, and thanks for all of the participants for this opportunity. I think that we will be checking the code and the slides and for sure the toolkit. And probably we can think in a follow-up call or a new webinar to keep talking about this. Thanks, everyone, and have a good day. Bye-bye.
Thank you.
Goodbye.
Thanks so much. Bye.